Okay, thanks for everyone coming back from lunch. I'm super humbled to be on stage today after so many talented folks that I've seen. One of my personal heroes, Steve Klabnik. Without his Rust book, I would probably not be here today, so thank you, Steve. It's so exciting to see Rust in so many amazing use cases like operating systems, server firmware, cars. I personally only use Rust to drive motorcycles, fly planes, and manage cute zoo animals. So obviously only that is possible in video games, and that's what we're going to talk about today. Over the last 5 years, I've used increasingly more Rust in my different companies. So who am I? I'm Stefan Dilly. I founded Game Roasters in 2019, sold it in 22. I'm the maintainer of the open source terminal UI for Git UI. And this year I founded Rust Unit, also focused on games, and I became the virtual Bevy meetup organizer. So if you haven't heard about that, please join me in the coming months. The goals for today are: how did Rust usage change over time for us? Some war stories, and where are we today, and what's the future holding? So we started in 2019 with a Go-backend, and we wanted to use some heavy AI calculations. So back in the days, it was usually something I would have used C for, but I was new to Rust. I was drinking the Kool-Aid, so I wanted to use Rust. So we started with using representative C on all the data types. That didn't really scale well. So we ended up using stringified JSON CFFIs to talk between Go and the Rust library that we were building. Calling C from Go back then was horrible. It was slow. There was all kinds of things you had to keep in mind with the garbage collector, with Go routines. So anyway, this was what we wanted to go with. Here's a little bit of code of that. It worked. On the front-end side, we use Unity, and Unity is written in, or the code that you write for Unity is written in C#. The CFFI integration of that is not too bad. That was really not a problem. Cross-compilation for iOS and Android, no problem. Our main platforms were iOS, Android, and web. Iteration times, though, were really slow because Unity basically requires you to reload the entire engine and the editor again if you change the library. You cannot hot swap out the shared library underneath. And obviously, we also had to use the stringified JSON CFFI. As you can see here, there's a lot of types that we had to redefine. This is the C# side, but there's also the Go side. There's the Rust side, so that all these 3 different languages can interop with each other. Ultimately, it solved the purpose that we had. We had a fast AI implementation for the game. But in conclusion, it was verbose, it was slow to use JSON across the boundaries. Go was particularly horrendous, as I said already. It was hard to maintain 3 different languages. Go in the backend was a viable option before we started to adopt Rust, but there was already things that we didn't like error handling. The package manager back then was basically not existing. And like I said, the iteration times in Unity with C# also not amazing. So what happened then was, end of 2019, we all know async await got stabilized. So we were super excited to build the next backend completely in Rust and finally get rid of Go and a lot of the problems that came with it. At the time, also more and more official driver support came out. One that we specifically needed for a client project was a MongoDB integration. So we were like, OK, we have everything to go and build this project for you guys in Rust. And luckily for us, they chose to say yes. Also not so lucky for us because it didn't go as well. Because what could go wrong if you write your first Rust backend, right? As soon as it hit production and 1,000 users per second were sort of hitting the server, it crashed every few minutes because it turned out the MongoDB driver, officially supplied by MongoDB, was broken. The connection pool had a problem in it. It was not super straightforward to find, but it, in the end, has to do with async drop. That ended up some connections not getting back into the pool. So we had to fix the official MongoDB driver. Here's the PR of it. It was, in the end, was not a super a super big diff. But to find that and debug that, as we all know, async code is not that easy. The same technology then ended up being used also in one of our first games, Wheelie Royale. I have actually a video of that. So essentially, it's a multiplayer motor game. You race and have to stay on your back wheel. As soon as you hit the front wheel, it's game over. So the further you make it, the better you are, the higher you make it in the ranking. And this thing uses Rust in the client, on the client side and on the server side. inside of Unity on the front end, obviously. That's still the case. So since this got more solidified in terms of how we use Rust, we needed to iterate on the front end integration. The back end was now fine. It was all in Rust, no problem with CFFI there. On the front end side, though, we were stuck with CFFI. But we improved our implementation from the JSON stringified thing that we used before to protobuf. That was solving a lot of the problems that we had. We got automated code generation for the languages. We were able to use a single memory buffer, which is also pretty important on the Unity side because we have to deal with the garbage collector there, and being able to serialize the entire request into a buffer and reuse that, and then have the other side also return the response into the same buffer without having to allocate anything anymore was a huge improvement over the stringified implementation that we had before. So we ended up having a simple code sharing solution with the backend between Unity and the Rust side. How did that look like? The API you saw before, it basically boiled down to a single function call now here, and this is what I was describing earlier. And the first project that we were using this in was called Tower Rangers, which was sort of an idle tower defense meets real-time duel game. And we have also a little demonstration of that here. Pretty good bass. So it was time, after we now had a more feasible solution on the front-end side, to improve the back-end, because this was still a single code base, monolith, copy-pasted from one project to the next. So what we ended up looking into at the time was Warp, because we were all still drinking the Kool-Aid, everything at compile time, and that's amazing. But we wanted to still have a modularized backend. So we ended up building different components, reusable for authentication, basically the whole toolchain you need for mobile games. Authentication, in-app purchase validation, push notifications, A/B testing, tracking, all the jazz. And it was all nicely wrapped in Warp. Hands up who has used Warp in the past. Okay. So some of you are familiar with some of the intricacies of it. So yeah, we called this the Atlas stack. It was using Warp. It was using some third-party crates that were luckily already there for single sign-in with Apple. And we all wrapped that into reusable and composable Warp layers so that you can choose for your project what you need. If you don't need in-app purchases, then you can leave out those parts, for example. And the nice thing that we invented for that was basically using what we call the static type dependency injection using HList. Anyone who has used HList here? It's magic. It basically allowed us to have a variable list of types that we used as the container for all the singletons, and then the different modules could pluck out of this HList at compile time the types that they actually needed to depend on. This is all open source on GitHub, by the way. And so if most of you haven't used HList, this is how it looks like. It's basically sculpting types. So what you can see here is the nice example of how you sculpt a specific subset of types out of this HList. And that is essentially what this dependency injection uses. And on the right side, you can see how for this stack 4 specific module that we have here, all the entire list of dependencies are defined up front, and then the different submodules can pick out parts of them that they are actually using in the end. Sounds very nice, right? So this is how it looks like, unfortunately, after Rust format had its go at it, because you still have to define explicitly which parts of the HList you want to sculpt out. And then this is, unfortunately, very nested types, and it works, but it looks really nasty. And then everyone who uses Warp in the past, you know this problem probably. All this compile time shenanigans leads to a ton of compilation times and crazy to debug errors because everything is in the type system. This whole list of endpoints in this REST API is completely defined at compile time. And if anything is wrong in there, you basically are back to C++ error messages. So last but not least, this was still released in an actual game called Stack 4, which was a real-time Connect 4 competition game, and also a little video of that. The only twist to the normal Connect 4 is that it's actually in 3D, so you can actually win around the corner to break your brain completely. Yeah, I think this one has no bass. Okay, so now we arrived at today. Today is probably the first time in history that I really think it's feasible to use a full-stack Rust implementation for a mobile game. As you can see, all these games were mobile first, with also like a web second, which was particularly problematic with Unity. So it was really something I was looking forward to be able to use Rust also for the front-end side of a game. And so, has anyone heard of Bevy here before? That's awesome. Okay, so I don't have to go too much into detail here. It's an ECS first, implicitly multi-threaded, and obviously blazingly fast game engine. It's based on a very modular plugin concept and supports all the major platforms that are at least important for us right now, including iOS, Android, and web. It's free and open source, so there's no risk of Unity licensing fumbling that actually made this whole thing relevant now this year, because companies are actually looking left and right for solutions and alternatives to Unity. And I was surprised to see that this community is so amazingly huge already, with 19,000 people on Discord. And they're all very welcoming and helpful if you're starting to get using with Bevy. So the first project that builds on Bevy is called Zoolitaire. It's basically a simple puzzling game. But it was our first venture into full-stack mobile games in Rust. So I think there's also a little video here. Yeah, so it's 100 levels of that. It gets more complicated, though. It's in the iOS App Store if you want to try it out. It's released on there. Oh yeah, pandas can stack, obviously. So what's the backend looking like now these days? We moved away from Warp. I bashed it enough to have to also come up with an alternative. And it is easier to modularize. It reuses the tower layers that were already there. It doesn't have to depend on HList to have dependency injection. The extractors are way more ergonomic. It trades the ergonomics for a little bit more runtime checks, but that's fine for us. And the good thing is we can reuse a bunch of stuff from our Atlas server library, because luckily we had a lot of stuff that was warp independent that we wrapped in warp layers, and that is now easily integrated into this new architecture. So in comparison to the earlier REST API that we saw in Warp, this is how it looks like with Axum. This is a server written with Axum. And it's way more easy to grasp, it's way more easy to maintain, and obviously not this crazy typing going on here. In the turn of the Zoolitaire release, we also were able to finally give back more to the community. So these 5 crates that are mostly essential for mobile-specific games with Bevy are giving you all the core functionality that you need for the native APIs on iOS, like making your phone vibrate, asking you and bothering you to review the app, showing alerts for errors that you don't want to replicate in the actual game UI, notifications, local and remote, to even pester you more. And in-app purchases, obviously, because someone needs to make money off of that. All of this is open source on GitHub, and we keep extending that, obviously, soon also for Android. And now, exclusive launch at the Oxidize Conf, the second game that we are working on. It's just very early, so bear with me that it looks like ass. But this is the URL that you can now all scan and play and try to reach the high score and beat me for some free Bevy stickers and a first adopter badge on the game. It is a similar racing game to Wheelie that we've seen before, and I would dare to switch to my browser now to show it. I promised you I fly planes with Rust. I hit the B. So anyway, I'm number 1 with 48 stars right now. Whoever can beat me will rack in the Bevy stickers. So please come later to me and show me your app or the browser, whatever you use. Oh, actually, obviously the app is not released yet, so please use the browser version. So let's go back to the slides. Oh, where's the cursor? Nice. Now I've lost everyone. Super smart. Anyway, we're almost at the end of the talk anyway. This thing uses Axum as I described before. It has a deterministic game logic, so unlike in Wheelie that we showed you earlier, this is not as easily cheatable. The same code runs on the server in Rust and on the client side, so it makes sure that what you played is actually true and you don't send me just some crap. And yeah, it uses the same code. The server replays the games. And we are pretty proud of that because this was one of the requests from our clients to be able to prove. And so, yeah, now we are at the end. I'm thanking you for your attention, or not now anymore, but also thanking you for playing the game. So please surprise me with a high score. If you want to chat, we have a Discord server, rustunit.com. We are available for contracting if you're interested. If Bevy needs to be used more in cars, as I've seen now, I'm there for it. Yeah, thank you.
Does anyone have any questions for Stefan? Here's one.
Are you aware that it doesn't always work?
Clear the cache, reload. It's pretty fresh. I literally released the last version half an hour ago. Hands up who it works for at least. Is there people? Ah, nice. Okay.
All
Sorry?
right, Firefox iOS. Yeah, so
awesome.
Hi, Stefan. I am curious about other people that you've brought on. Maybe, I don't know how big your team is, but one of the criticisms that people often have is, I can't hire Rust engineers, I can't train them. What has your experience been introducing people from the game industry where Rust is far less common?
I find it interesting to hear these comments because my experience is that teaching people Rust is actually way easier than its reputation is. Because especially when you take on not the, I mean, there's two sides to the story, I would say. It's a very complicated answer, but thank you for the question. The people with experience, without Rust experience, usually are easy to onboard because if they are decent developers and they have the right understanding. Of course, there's a little bit more of this gap to jump over of, but I have to unlearn so much stuff, and the borrow checker hates me. And that's still possible to deal with by just not worrying about lifetimes in the first place initially. And then there's the people who don't have that like wrong learning in the past, and they are even easier to onboard. So my best experiences so far, and also due to budget, is to hire very junior people. And the curiosity for Rust is gigantic. People from the universities are all looking into Rust by themselves already anyway. And I think the lack of Rust in games industry is only because it just takes a long time to be adopted by companies that really have legacy and big teams that need to be migrated. If you ask for people in the industry, they're all super curious about Rust. They would love to jump on it and have prototypes with it.
Any other questions? Not here. I have a quote. Oh, we've got one here.
By searching for an alternative for Unity, did you, I mean, you ended up with Bevy, but did you try out Godot?
Yeah.
How was that?
It's not like I don't like Godot, but I like Rust more. And the Rust integration in Godot is really, I must admit, I didn't check out the 4.0 version of it, like compatible with the 4.0 Godot version, but the old integration for Rust was super complicated, basically fully unsafe, so it didn't really feel like Rust that you had to use there. So that was one of the reasons for not using Godot for Rust games, but as a general games engine, I highly recommend using it for quick iteration, prototyping, whatever. It's really great.
Okay, then I do have one more question. Yesterday with our panel, we were talking about that, I asked Till the question about that inflection point. When do people decide to move from one software to another or move to Rust? You, with your company and organization, made that change. What were sort of the things that you evaluated to make the decision to move to a full stack Rust development?
I mean, it's based on the history that I described in this talk. It was coming from the building up of expertise and confidence of the projects over the years that led us to believe that now it's really time to give it a shot as a full-stack programming language for games. Obviously, it was way easier to start applying it in the backends in the years before, because it was less of a shift, because you didn't have to switch out the engine, the front-end side of the games. And on the server side, traditionally, people don't even care as much anyway for what they use. It's just the fanciest and nicest and fastest tool is the best. So there was no barrier there. But now it's really, I think we are in a very early phase of trying to adopt it on the front-end side. But I believe that the future will belong, at least in some parts, to technologies based on Rust in the video game front-end engine space.
And will you be developing games soon for other platforms other than mobile?
We would love to. We are still looking for clients for that. And obviously, I would really love to push forward console adoption for Rust, because so far there's nothing on the major consoles that supports Rust.
Maybe next year you'll be here telling us about it. Thank you so much, Stefan Daly from Rust Unit, talking about video game adoption. So thank you.
Thank you.